Welcome back to another Make Math Make Sense Master Classic Math video. If you're new to the channel, we're just going through these skills in Khan and we're trying to make them make sense. We're trying to make them easy. Today we're in the Algebra 2 course in the polynomial factorization unit. We're going to cover greatest common factor of monomials. If this video helps you out, please like it. That way I know that, well, I made a helpful video. You know what I'm saying? That's certainly positive or good feedback for me to know that. Alright, greatest common factor, just to give you a little recap, I've got a little definition for you. We're factoring monomials here, but GCF, the highest number or expression, we're using expressions here that divides into two or more numbers or expressions. I put expressions because these are expressions, they're not just numbers, right? There's a variable component to them as well. So, what is the greatest common factor of 54z to the third, 18z, and 36z squared? We're just trying to figure out what's the largest number that divides evenly into all of those numbers, and how many z's do they each have in common that are being multiplied, right? So there's kind of two parts here. There's the number part, and then there's the variable part. Here's how we deal with the number part. We've got 54, we've got 18, and we've got 36. Okay, we can divide them all by 2, and 2 will go in evenly, right? But that's not the largest number that we can divide them by, right? We could check a bunch of different things, but the reality is here, if I want to find the greatest common factor and I'm allowed to use decimals, I'm going to type in GCF, greatest common factor, and then I'm going to type in the first number 54, comma, the second number 18, comma, the third number 36, and it's going to tell me that the greatest common factor, or the greatest number that we can divide them all by, is 18. So 18 is a number that goes into all of them evenly, and it is the largest number that goes into all of them evenly. So our greatest common factor, the number portion, is 18. Now the variable portion, we've got z to the third, which is the same thing as z times z times z. The second expression has just a z, which is the same thing as just z. And then we've got z squared, which is the same thing as z times z. And so for this portion, we're just trying to figure out how many z's can we pull out of each of them. How many do they all share? Well, they all share at least one z. And that's it. This one's got 2. This one's got none. This one's got 1. So we can only pull out of all 3 of them. We can only factor out 1z. We can only divide them each by 1z because they each have at least 1z. So our greatest common factor here is 18z. Punch it in, catch the green, and move on. It's the greatest common factor of 44c to the 5th, 22c to the 3rd, and 11c to the 4th. Again, we can just type in GCF with those 3 numbers and we'll get the greatest common factor. Another way of thinking about this is to put the prime factors out. So if I was to prime factor 44c to the 5th, I'd have 2 times 2 times 11 times c times c times c times c times c. Those are the prime factors of 45c to the 5th. 22 would be 2 times 11, and then we've got c times c times c. This is just another way of thinking about this problem. You can just do the same thing that we did in the last one. 11 would be 11 times 1, right? So 11 times c times c times c times c. So those are the prime factors of each. And if I want the greatest common factor, then I'm just saying in common, what do they all have? Well, they all have an 11. So we can factor out an 11 out of all of them, right? So our GCF, the number portion here, would be 11. Same thing we would get if we typed them into decimals, right? And then for our variable, we're just counting up how many we can pull out. So they have 1 c, they all have at least 2 c's that we can pull out, that we can factor out, and it looks like they all have at least 3 c's. We can't pull out a 4th c, this one's missing one, so the most that we can pull out are 3 c's, so c to the 3rd. And that's how we find the greatest common factor. That's another way of thinking about it. Just look at the numbers though. I mean, this one's got 5, this one's got 3, this one's got 4. How many do they all have? They all have at least 3, right? So, I mean, it's essentially that easy once you kind of understand what you're doing, right? Okay, greatest common factor. I'm just going to go ahead and rip through this one because why not? We're going to go ahead and punch it into decimals. We're typing in 60 and 36 and 24. Cool. The number portion here is 12, and then I'm just looking at how many W's I can pull out. This one's got 1, this one's got 2, this one's got 4. How many do they all have? They all have at least one. 12W. Boom, done. Cool. Greatest common factor, 35, 5, 15, and 5. Cool. I'm not even going to type this one into Desmos. We both know that the largest number we can divide them all by is 5. Can't divide 5 by anything larger than 5. And then this one's got 2 B's, 3 B's, and 1 B. How many do they all have? They all have at least 1 B. And that's how I find the greatest common factor of monomials. Hit the like button if this helped. If it did not, then obviously do not hit the like button. I'll see you again for another Make Math Make Sense Master Classic Math video. Good luck.